Hello everyone, we are back again in our channel Scientific Officers Association Geological Survey of India. Today we will be demonstrating the graphical determination of strike and true dip of any bed where two apparent dips are given. So it will be a short exercise because we have explained the concept of strike, true dip, apparent dip in very much detail in our earlier two videos, and in case if you are unable to follow the instructions, then you have to go through the last two videos. So let us start. So this is the problem. The apparent dip of a bed towards 135 degree is 35 degree and towards 200 degree is 60 degree. So determine the strike and true dip of that bed. So for that, what we need to do is we have to take the help of our plan and section as we demonstrated in earlier videos. So to give one small 3D demonstration, I am constructing one cube for the timing. So suppose if this is the inclined bed A, B, C, D, if it is the inclined bed, so we have been given two amount of apparent dip on it, and we have to construct the strike line on that bed. So of course in this cube this is the true dip and this line is the strike, but here we are given two apparent dips. Suppose this is one apparent dip given and this is another apparent dip of that bed. So on the basis of these two apparent dip, we can calculate the strike and true dip of that bed with the help of some construction of section and construction of plan. So for this construction, let us take one scale. Scale is mandatory. Suppose for convenience, this is 1 centimeter equivalent to 100 meter. So in this part we will be constructing all the sections, and below we will be constructing the plan view. So this part will be sectional view, and below the whole page will be used for plan view. So in plan we need to mark the north south and east west. So suppose this is the center, let us draw the north south line, north or 0 degree, south or 180 degree, and by protractor first we need to mark the center with proper divider, and now with the help of protractor we will be drawing the east-west line this is the east or 90 degree, and this is west or 270 degree. So this is the plan view, plan, and above sectional view. So now we don't have any information about strike line. We have to derive that, or we have to construct that with the available data. What data are available? Only two apparent dip are given. One is towards 135 and another is towards 200. So in auxiliary sections we need to draw two sections. This point is O at the center. So we need to assume this plane, this inclined plane cutting through this O, be it like this, be it like this, it has to cut through O. Suppose this is the inclined plane, it has to cut through O. Suppose this is the inclined plane, it has to cut through O. So O will be one point on that inclined plane. So this is the 0 meter level, this one, and by divider we will take that 1 centimeter distance. We are using divider because it will cause minimum error. So this is minus 100 meter level, or the intersection of this section with minus 100 meter horizontal plane. This is it. This is the section. Hope you can understand. Now 35 degree is one apparent dip. This is 35 degree here. So this is the inclined plane, trace of that inclined plane. Now the trend is, this direction is 135 degree, trend of this section, and this direction is plus 180, 315 degree. So for getting strike spacing, what we need to do, this is the intersection with the strike line. Suppose OX, this is the strike spacing, and the trend is 135 and 315. So now the strike spacing between 0 meter and minus 100 meter stratum contour we have got, and that can be plottable on the plan. We will plot this strike spacing in proper direction. So the direction is towards 135. So azimuthal direction of 135 degree will be this. This is the 135 direction. This is the line 135 and 315, and we have to take this OX strike spacing, and we will be plotting this strike spacing on that line. This is the OX, this is the point OX, For convenience of understanding, I have put this circle. This is 135 and 315 trending horizontal line on the plane, and this OX is the strike spacing of 0 meter and minus 100 meter strike line along this 135 direction determined from apparent dip. So one strike spacing we have got already. So what we need to do is we have to find another strike spacing by applying this data 60 degree towards 200 degree, and since the scale is same, it is upon us whether we need to construct another vertical section beside this, or we can do the similar exercise on this graph only. That time, in the second case, we have to change the direction or trend of that vertical section. That will be 200. If you add 180 with 200, it will come 380. So you have to deduct 180 from 200, that will be 20. So this time the section trend will be 20 and 200. The same section we are using. Instead of drawing another section, it will save your time, but in exam you do separately, don't take risk. But for normal calculation, for saving time, you can do the same exercise in one single auxiliary vertical section. So what we will be doing now, that 60 degree is the amount, this is the 60 degree plane, this angle was 35 degree and this angle is 60 degree. This angle was 35 degree and this is the 60 degree. So with the similar logic, and here now the trend has become 200 degree and 20 degree in the second case. So applying similar logic, we will get another strike spacing called OY, on which direction? 200. So in plan we need to mark the 200 trending line. This is the 20 and 200 degree trending line. So we'll again measure the OY distance by divider and we'll mark it on that 200 line. So this is the X and this is the Y point, and both are representing the stratum contour of minus 100 meter. So the plane must go at depth just vertically 100 meter below 2 points. That is the logic of stratum contour. So if we connect these 2 points, we will get the minus 100 meter stratum contour, and we know minus 100 meter or minus 200 meter stratum contour for a homoclinal means constantly dipping bed where there is no rotation, no change of strike. Then the strike line or stratum contour are parallel. So from this we will get, by connecting X and Y, we will get the minus 100 meter stratum contour. So by connecting through this dash line, we will get minus 100 meter stratum contour. If we measure the azimuth, we will get the strike line, attitude of the strike line. So here it is roughly 111. So the strike of this bed is 111 and 291 degree. So we can tell the strike now 111 degree and 291 degree. Now true dip we need to calculate true dip amount. Now of course we know the true dip direction, that is perpendicular to the strike, but we need to construct the 0 meter strike line. And what is the logic of drawing 0 meter strike line? That will go through the center O, as here the O point always lied on the 0 meter level. So the 0 meter strike line will also cut the point O, maintaining similar strike. So by set square we need to draw this. In set square you can see why do we use for constructing parallel line. This angle is 90 degree, this angle is 90 degree. This is one plane or one line, and this is one line. So if we move this along the perpendicular side of the set square, the line here and the line here is parallel. So for constructing parallel lines, first we need to set the set square on the line, and then we need to fix another set square on that O point, since the parallel line will run through the O. And here this is the 0 meter stratum contour running through O. Since strike line is infinitely extending practically, so we have to put arrow, and this is 0 meter stratum contour, and this is minus 100 meter stratum contour. So perpendicular to this will be the true dip direction. So for this case it is quite clear that the second data given, that is 60 degree towards 200 degree, here the true dip direction is 111 plus 90, that is 201. Pretty close to the true dip direction, the apparent dip given, with the difference of only 1 degree. So this is the spacing, strike spacing, and in the same diagram we are plotting the strike spacing. Now the reverse, because we need to calculate the dip. So this is OZ, suppose. You can see this point was OY, and just a little bit, means 1 millimeter smaller strike spacing, because true dip is the maximum one, so the strike spacing will be the minimum. So this OZ is the strike spacing, and now the vertical section trend has become 201 and 21 degree, because that is the 201 is the true dip direction. So for construction, as I explained in detail in last session, that we need to project vertically downward the Z point and find the intersection with minus 100 meter level, and then we need to connect this minus 100 meter intersection, 100 meter horizontal plane intersection with O point, and now we'll see the dip. It is coming around 62 degree. This angle is 62 degree. If you look at it closely, you will be able to find the difference. This one was the 60 degree line, and this is the true dip 62 degree. So the true dip amount is 62 degree and true dip direction is 201 degree. Why it is not 21 degree? Because 0 meter strike stratum contour is here and minus 100 meter strike stratum contour is at the southern side. So the bed is dipping like this, not like this. If the bed dip or true dip was towards 21 degree or northeasterly, then we would have created this minus 100 meter stratum contour on the northern side. So this is why we can now write the attitude of the bed as 111 degree, 62 degree towards 201 degree. This is the true dip of this bed and answer. So that is all for today. Hope you will be able to construct the true dip from apparent dips graphically. This is called graphical method by stereonet. We will be explaining in future sessions, and with that, one important information: in field sometimes for gently dipping beds we get confused which one is the actual true dip direction. Though there are ways. Suppose if you pour some water on an inclined plane, it will follow the true dip direction. So by that way you can, but suppose you don't have water at that time, then what will you do? So for that you can easily measure two random apparent dip on that plane, and in that field itself, without having stereonet, by this way you can easily construct the true dip and proper strike of that bed in field within 5 minutes. So for that reason, this exercise is very important from practical point of view. So that is all, and if you find this video useful, please do like our channel. If you find any difficulty, you can write in comment section, and please do subscribe our channel. That will motivate us more and more to make such videos which will be helpful for many. So thanks a lot from Geological Survey of India Scientific Officers Association. Thanks.